We're looking at Chapter 2, Reasoning and Proof, and we are going to go over geometric proof, segments, and angles. So we're going to start off looking at different rules, definitions, and postulates, and figuring out what does it look like inside of a geometric proof. So we're going to start with segment addition postulate. Segment addition postulate simply says that the sum of two smaller segment lengths is equal to the length of the combined segment. So if we give you that statement here, we have AB and BC. What we would do is we would write AB plus BC is equal to AC. The reason for that is the segment addition postulate. Now, one thing to pay close attention to here is we're talking about measurements when we do the addition. So notice here we do not have the lines over it. We're not doing the segment lines because we're not talking about the figure themselves. We're talking about a measurement with them. And therefore, that is why it's equals. If a postulate or a definition gives us congruence, then we would put the segment lines over the top. Let's keep going. Angle addition postulate. The sum of two smaller angle measurements is equal to the measure of their combined. So when we look here, I'm adding again, and I'm looking at equals. So measure of angle 1 plus measure of angle 2 is equal to the measure of angle ABC. And that is by the angle addition postulate. Okay, let's go to midpoint. What does midpoint give us? So definition of a midpoint splits a segment into two congruent parts. So if we told you M is the midpoint of AB, now we're going to congruent. So we're going to go segment AM is congruent to segment MB, and that is by definition of midpoint. Next, we go to the definition of a bisector. A bisector splits an angle or segment into two congruent parts again. So since we're dealing with congruence, we're not going to use the measure. We're going to use the angle themselves. So BD bisects angle ABC, which would tell me angle 1 is congruent to angle 2. And that is by definition of angle bisector. Okay, we also have a segment bisector, same idea. A bisector splits an angle or segment into two congruent parts. So if N bisects AB, then what we know is AM, the segment, is congruent to MB, the segment. And that would be definition of segment bisector. Okay, next we have definition of vertical angles. The definition of a vertical angle says vertical angles are opposite angles formed by two intersecting lines. Their angle measures are equal. So again, we're looking at the measurement here. So if I know angle 1 and angle 2 are vertical, then I know the measure of angle 1 equals the measure of angle 2, and that is by the definition of vertical angles. Okay, next we have definition of complementary angles. Complementary angles are two angles whose angle measurements sum up to 90. So again, we're talking about the measurements. 1 and 2 are complementary, so we know the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And that is by our definition of complementary angles. Okay. Supplementary angles, very similar to the complementary, except for they sum up to 180. Again, we're talking about a measurement here. So we're going to do the measure of angle 1 plus the measure of angle 2, and that equals 180 degrees. And that would be by the definition of supplementary angles. Then we have this definition of a right angle. An angle is a right angle if and only if. So remember, We call that a biconditional because it goes both ways. So when we write our statement, if I'm told that angle B is right, then I also know the measure of angle B equals 90 degrees. Definition of a right angle. But I also know it can go the other direction. So by it being a biconditional, if I know it equals 90 degrees, then I can also say angle B is a right angle. And that is, again, by definition of right angle. Okay, linear pair. Now, linear pair is kind of special here because the linear pairs, they tell me that they are adjacent and supplementary. So we do not know what they add to, we just know they're supplementary. So angle 1 and angle 2 are a linear pair, then angle 1 and angle 2 are supplementary. And that is by definition of a linear pair. Okay, definition of congruence. Now, this is a big deal. We use this a lot. Definition of congruence says a segment or an angle are congruent if and only if, again, that biconditional, if they have the same measure, which means this can go forwards and backwards. It can go both directions. It's a biconditional again. So if I'm told angle ABC is congruent to angle DBE, then I know that the measure of ABC is equal to the measure of DBE. And that is by definition of congruence. If I know that the measure of angle 1 equals the measure of angle 2, then I also know angle 1 is congruent to angle 2, again, by the definition of congruence. So we use that going forwards and backwards. In statements, if I know AB with the line segment over it is congruent to CD with the line segment over it, then I also know their measurements AB is equal to CD. Again, definition of congruence. Likewise, if I know they're equal, then I know that the segments themselves are congruent. So it works both directions there, being that biconditional. All right, so let's practice this into a geometric proof. So here's what we're given. T is the midpoint of SU, and we have the statements all filled in. We want to come up with the reasoning. So always in a proof, you're going to want to start with the given. T is the midpoint of SU. And that the reason is always given. Now, look for, when you look at writing a proof, you always want to ask yourself, okay, what vocabulary and how can I use it? Well, if I know that it's a midpoint, by the definition of midpoint, then what I know is that those two segments, ST and TU, are congruent by the definition of midpoint. Then if you look from line 2 to line 3, the thing that changes is it goes from congruence to equals, and that is by definition of congruence. Now that we have them equal, we're now talking about the measurements of them. So now we can substitute in. Okay, so we're going to substitute in the measurements. Now we start to solve. Here, if you notice, you're going to minus the 2x from both sides is what they did. So that is subtraction. And again, we're going to minus the 3, and that is the subtraction property as well. And that is how that all falls into that proof. Let's try another one here. So here, we're going to start with the given. Angle 1 and angle 2 are supplementary. Angle 1 and angle 2 are supplementary. And the reason for that is it is given. Then they change it to the measurement. Supplementary, measure of angle 1 plus measure of angle 2 equals 180. That is by our definition of supplementary angles. Then, now we have it equals. So now what we're going to do is we are going to substitute in the values. And now we're going to combine like terms. So you can say collect like terms. Or I like to call it substitution because we know what that is equal to. We know that 10x and 7x put together equals 17. So we're taking two things that we know are equal, taking it out, putting in the number. Likewise, the negative 4 and the positive 14, same thing to get us the positive 10. Then at that point, we need to move the 10, so we would subtraction property. And then we would be doing the division property. And then as you're finishing, you always want to make sure, is my proof statement what it's supposed to be? Okay? All right, let's try another one here. So this time we're not giving you anything but the given and the proof. So that we're going to start off with the given, SU equals 19. And that is the only thing that we are given. So now we start looking at the picture, the diagram, what I'm given. And here's what I know. I know that S to U, that is 19. So if I think of that, how could I use that? Well, one thing I know is that T is between those. So I know that ST plus TU, that equals SU. And that is by the segment addition postulate. Then, once we know that, we have it equals, so now we can plug in values for each one of those, and that is our substitution property. Then, now I can put some things together, so 2x plus 23 equals 19. Again, I call that substitution. I will also accept collecting like terms. It is not the addition property because remember the addition property of equality says that we're adding the same thing to both sides. Then we would subtract the 23 and we get 2x equals a negative 4, and that is our subtraction property of equality. And then our last step, we get x equals negative 2, and that is our division property. Okay, so that's what it looks like. I check my proof. That's exactly what I have. So we are good to go. All right, let's try another one here. So here they give me the measure of angle ABC is equal to 89 degrees. That's my given. Okay, and they want me to prove that x equals 9. So I look at this process. I know that ABC, this big angle, that is 89 degrees. So now I need to figure out how do I get to the other pieces. So here's what I know. I know that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC. That is by angle addition postulate. Then I can substitute some values in. So I know 6x plus 5 plus 3x plus 3, and that equals 89. That is by the substitution property. Then I'm going to put some things together here. So I have 9x plus 8 equals 89. Again, I call that substitution. If you want to call it collecting like terms, I'm okay with that. And then at this point, we're going to subtract. So we get 9x equals 81. And that is through our subtraction property. And then I would divide and I get x equals 9. And that is through our division property. And there is our proof. That is exactly what we wanted to prove here. All right, let's keep going. A couple more here. So y is a right angle. The measure of angle y is 4 times the quantity 10 minus x. So what do we know? Well, here's where we can go. We know that they're giving me right angle for a reason. So what I know, or what that tells me, is the measure of angle y is 90 degrees. And that is from the definition of a right angle. Okay, then at that point, I can substitute in. Okay, then we can distribute. So 40 minus 4x equals 90. That is our distributive property. Then at that point, I would subtract my 4x. That is our subtraction property. And then at that point, I'm going to do my division. And that's going to get us 12.5 negative. And that is our division property. And we double check. That's what I wanted to prove. So we are all good there. Okay, we got 3 more here to go through. So we start off, angle MJGK and angle PGK are a linear pair. And I'm going to be proving something with algebra here. So I'm going to start off, I know they're a linear pair, so what that gives me is MGK and angle PGK are supplementary. Okay? And that is from the definition of a linear pair. Now that I know that they are supplementary, then I know the measure of MGK plus the measure of angle PGK equals 180 degrees. And that is definition of supplementary angles. Then we can substitute now. MGK is 9x plus 13 plus PGK is 7x plus 7. And that equals 180. And that is by our substitution property. Substitution property. Then we would do some combining of like terms. So I get 16x plus 20 equals 180. So you can either do collecting like terms, or I like to write it as a substitution. Either one, though, I will accept. Then we would subtract. So 16x equals 160. And then at this point, we would end up with x equals 10 by dividing. All right, let's try this next one here. Starting off, angle 1 is congruent to angle 3. That is given. Then they tell me that measure of angle 1 is equal. That is by our definition of congruence. Then if we look at this, they tell me that measure of angle 3 plus the measure of angle 2, that is equal to the measure of angle ABE, and that is by angle addition. Then they tell me that angle 1 plus angle 2 is equal to measure of ABE. Now, if you look at that angle 1's not even involved with that. So where are they getting that from? Well, that comes back to the given. What they're doing here is they're taking measure of angle 3, and because angle 1 and angle 3 are congruent to each other and also equal, then they can substitute. So they are substituting the substitution property. Then at that point, they are going to substitute what measure of angle 1 plus measure of angle 2 actually is. That is CBD, and that is by angle addition. And then once they're there, we can just say that the measure is equal to the measure, and that is by substitution again. Okay, and our last one here. If I tell you that angle 1 is right and angle 1 and angle 2 are a linear pair, I want to prove that angle 2 is a right angle as well. So here's what I know. By the definition of a right angle, then I know that the measure of angle 1 is equal to 90 degrees. And that is the definition of right angle. I also know by the linear pair, I know that angle 1 and angle 2 are supplementary. And that is definition of linear pair. Then at that point, if I know they're supplementary, I know the measure of angle 1 plus the measure of angle 2 equals 180 degrees. That is based off the definition of supplementary. And then at that point, I can substitute in. So I know angle 1 was 90. Okay, and that is substitution. Then I'm going to subtract, so I know measure of angle 2 is equal to 90 degrees. That is from our subtraction property. And then that tells me that angle 2 is a right angle. And we know that by definition of a right angle. Okay, and that is how we write our geometric proofs.